Hello everyone and welcome to Say It with Symbols 4.2. Our learning target here in Investigation 4 is we'll be able to solve problems, both linear or quadratic, set in real life situations and be able to write an equation given 2 points if the relationship is linear, quadratic, or exponential. Our ACES questions for 4.2 are numbers 7 and 31 through 37. Well, 4.2 here starts on page 68 in our book. And in this problem, we're going to substitute equivalent expressions for quantities into a given equation and write equations for area and profit. Now, in the last problem, we were given an equation that represented the amount of water remaining in a pool at a given number of hours after the draining had started. In this problem, I have two different situations described, both, as I said before, area and profit. Now, you used an equivalent form of the equation that they had given you to make sense of the pool situation, and you did that by expanding it so it was easier to use for that situation. Now, you may want to rewrite equations for these area and profit problems to make them more helpful as well. So in this problem, Tony and Paco will plan to run a concession stand and rent water tubes to the visitors at Watertown. Tony's trying to find the maximum area of the concession stand given a fixed perimeter of 88 meters, and we see that here in part A. We're working with Tony and trying to get the largest area out of a fixed perimeter, again, of 88 meters. Now, this is very similar to one of the problems we worked on in frogs, fleas, and painted cubes, so you might want to go back and check your notes and some of the problems you worked on for frogs, fleas, and painted cubes. Now, for number one, you need to write an equation for area in terms of length. Try to remember how we can write width in terms of length. That's the clue I'm giving you. We did the same thing in frogs, fleas, and painted cubes. So again, check your notes if you need to, but how can we write width in terms of length? Then, from that equation, determine what is the maximum area for the rectangular floor space. Then in part B, we're working with Paco and the tube rentals. Read this information up here very carefully, very carefully. Ask yourself, after you've read through this and all the information they're giving you, do equations 1 and 2 match what you know about the conditions? As in, does n equals 54 minus 1 times p and I equals n times p? Do those represent what you know about the situation that they tell us here? Um, Once you've determined whether that makes sense with all the information they've given you, write an equation for income in terms of the number of rentals. Okay, and then what we want to do is look at the expenses information that they give you here, which is $10 per day, and write an equation for daily profit D in terms of the number of rentals N. Remember, profit equals income minus expenses. So profit here is income, the income you make, which is up here in part 2, minus your expenses. Okay? Then in part 4, what number of rentals produces the maximum daily profit? What is the maximum profit? And what price produces that maximum daily profit? Then I want you to think, does this equation that you came up with in part 3 and maybe had to reorganize that, does it have any similarities to Tony's equation in part A? And if so, can the same equation be used for more than one situation? And hopefully you can see the connections there. Good luck with this. I look forward to your questions and comments in class. And remember, our ACES questions for 4.2 are 7 and 31 through 37.